In constructing motion diagrams, it's a good idea to use 4 dots minimum. That's usually enough information to give us an idea of what the motion diagram looks like. I have a reference line drawn here for each of these. The first one says a car is traveling towards the right at constant speed. Let's agree that towards the right is positive, and that's the negative direction. We're moving at constant speed, so that means that the distance between all the dots is exactly the same, and then we draw an arrow from dot to dot, and this distance is always the same, indicating that the object is moving at a constant speed. In question 2, the car traveling towards the right is increasing its speed, so it has a positive acceleration. So it's moving towards the right. We start over here. We are increasing speed, so that means that the distance between the dots is getting larger. So I'll start off with a small space, and then it increases, and then it increases. So that would be the first distance covered, that would be the second distance, and that would be the third distance. So the distance between the dots is ever increasing. In question 3, a car traveling towards the right is decreasing in speed. So it's slowing down. That would be the vernacular. Now in this case, since it's decreasing speed, that means that we have a negative acceleration. Now if it's decreasing speed, that means that the force is acting towards the left, which makes the acceleration acting towards the left, and that's why it's a negative acceleration. So it's slowing down. So there's our first dot. That means it starts off going fast, and the dots are getting closer and closer. But remember, it's moving towards the right, so this indicates moving towards the right, moving towards the right, moving towards the right. Now we have a car traveling towards the left at constant speed. Left is the negative direction, so that's negative v. So we're moving towards the left, so I'm going to start over here. That's the starting point. Constant speed would be constant distance between dots. So moving towards the left, towards the left, towards the left. 5, a car traveling towards the left, which is negative direction, at increasing speed. So it is speeding up in the left. Well, it speeds up because there's a force towards the left, which makes the acceleration towards the left. So that's a negative acceleration. So we start off over here, and it's speeding up towards the left. And that's what that looks like. And let's indicate that it's moving towards the left.
With the following students, please report to guidance. Wilbert, Joseph, and Ben Call to guidance.
Do you hear that, Wilbert? Okay, question 6. A car traveling towards the left at decreasing speed. Moving towards the left.
Following students, please report to the main office.
Sorry about that, but that's teaching. And it says it's decreasing speed, so it means it's going fast initially. That means it covers a large distance initially, and the distance gets smaller and smaller as time goes by.
John Hatchadorian to the main office. Thank you.
So we do that, and do that. So this is the start. We're moving towards the left, and we are slowing down, which means we're covering less and less distance as time goes by. Number 7, we have an air hockey puck moving to the right with negative acceleration. So now I'm kind of changing the terminology here. I'm using the term negative acceleration. That means the force is in the same direction as the acceleration, but we're moving to the right. So we start here, and what's happening? We are slowing down, right? Because there is a force acting on us. So that means initially we travel a large distance, then we travel a smaller distance, and it just gets ever so small. And then the last one, air hockey puck moving to the left with negative acceleration. So it's moving towards the left. So we're going to start over here, negative acceleration, negative A. That means the force is in a negative direction. I'm moving towards the negative, so it means that it's going to be speeding up because the force is going to push it along. So it starts off covering a small distance, and then the distance gets ever so larger. And that's your homework.